Hello everyone, welcome to Shiv's classes. In today's lecture, we are going to discuss problem number 3, 4 and 5 of chapter 3.2. So, we had discussed in last lecture as to how to interpret this problem, but we will do it again over here. So, first of all, let's draw the coordinate axis and try to read through the problem as well. So, let's read the problem. So what is the problem saying over here is that cotx is given as 3 by 4 and x lies in the third quadrant. So this is my first quadrant, this is my second, this is my third, and this is my fourth quadrant, right? In first quadrant, everything, all trigonometric functions will be positive. Here only sine and cosec would be positive. Here tan and cot would be positive, and finally here cos and sec would be positive, right? So we had discussed this, and then maybe we'll have to go through the proof once again just to understand why it is so. But if you look at the coordinate axis, which is x-axis, this is x dash, y-axis, y dash. So you know that y is positive and x is positive in this quadrant, and y is positive and x is negative in this quadrant. X is negative and y is also negative in this quadrant, and x is positive and y is negative in this quadrant. And if you remember the trigonometric and functions, you know that the value of sine theta is nothing but p by h. Value of cos theta is nothing but b by h. Value of tan theta is nothing but p by b. Alright. So all these values you know that p, and if you can create a figure like this, if this is your theta, this is your p, and this is your h, you know that p is positive in the first quadrant, p is as well positive in second quadrant, but p would be negative in this quadrant, and similarly your b as well will be negative in this quadrant, and your finally p would be negative but h would be positive, p would be negative but p would be positive in this quadrant. So because of this reason only, sine theta is positive here and here, while cos theta is positive here, while tan theta is positive here, because p and p both are negative. So we had discussed this in previous lecture as well. Here as well we have discussed, so now you know that what is the reason that sine, cos and tan are positive or negative in various quadrants. Now try to solve this problem. So we have been given cotx equals to 3 by 4. So what we can get, tan x from here, we can get tan x equals to nothing but 1 upon cotx, which is nothing but, you can see, it is 3 by 4. So 4 will go up, so it will become 4 by 3. Now we have got cot and tan. We know that another trigonometric identity, which is sec square x minus tan square x equals to 1. Right? Now given this, we know that sec square x equals to 1 plus tan square x. Given this, we know it's 1 plus 4 by 3 whole square, which will be nothing but 1 plus 16 by 9, and it will turn out to be 25 by 9 if you sum it up. Or let me just do it one more step. Let's not skip any step here. So if this is my 9, then 9 will be LCM, and this 9 plus 16 would be 35 by 9. So this implies sec square x equals to 25 by 9. This implies sec x is square root of 25 by 9, which will be nothing but plus and minus of 5 by 3. But since it's given it is in third quadrant, we know that sec theta would be negative in third quadrant, only cot and tan would be positive. So sec x would be nothing but minus 5 by 3. as sec x is negative in third quadrant. Given this, we get cos x equals to 1 upon sin x, which is nothing but 1 upon minus 5 by 3, and we'll get minus 3 by 10. So now we have got sec x, we have got cos x. Now can we get sin x from here? So sin x would be nothing but 1 minus cos square x square root. Why? Since sin square x plus cos square x equals to 1. So this will give me 1 minus cos square x. 1 minus cos square x is nothing but minus 3 by 5 whole square. Alright. Now what you will get here is, you will get 1 minus 9 by 25, which will be again 1 minus 25 minus, rather let's write, take LCM 25 minus 9, which is your 16 by 25, which will be plus and minus of 4 by 5. Again, sin x would be negative in this. Sin x would be negative in this quadrant. So you will take sin x equals to nothing but minus 4 by 5. Given this, you can get cos x equals to 1 upon minus 4 by 5, because it is cos x is nothing but 1 upon sin x. This will give you minus 5 by 4. So we've got all the trigonometric identities. You can see these are my trigonometric identities, right? Now let's go to the next question. Next question is, again we got to find out all other trigonometric functions given sec x equals to 13 by 5 and x lies in fourth quadrant. So just again remember, in other words, what we remember is add sugar to coffee, right? So what is happening over here is sec x is in fourth quadrant. Here cos and sec would be positive, right? So that is why sec x is 13 by 5. So given sec x, we get 13 by 5. So we can get cos x is nothing but 1 upon sec x, which will be nothing but upon 13 by 5, which will be 5 by 13. Now we have got cos, we have got sec. Can we get tan? We know that sec square x minus tan square x is equals to 1. This implies 13 by 5 whole square minus tan square x equals to 1. This gives me tan square x equals to 1 minus. So I'll have to go that way, sec square theta minus tan square theta equals to 1. So then tan square theta will go that side, sec square theta will come this side. So it will be 13 by 5. I have sent tan square x on the other side. So it will be 13 by 5 whole square minus 1. This implies tan square x is equals to 13 will be 169 divided by 25 minus 1. This will be 25 will be LCM, and it will be 161 minus 20. 169. This is 169 minus 25, which will be 144 upon 25. This will give me tan x equals to the square root of 144 upon 25. So this will give me 12 upon 5 in plus and minus. But we know that tan theta would be negative in fourth quadrant. This will give me tan x equals to minus 12 by 5. Why? Because tan x is negative in fourth quadrant. Now we have got tan x. So can we get cotx? Yes, cotx would be 1 upon tan x. Now 1 upon minus 12 by 5, which will be minus 5 by 12. Coming to sin x, so sin square x plus cos square x equals to 1. This implies sin square x equals to 1 minus cos square x. It will be 1 minus 5 by 13 whole square from here. So it will be 1 minus 25 by 169. 169 would be the LCM. So it will be 169 minus 25. So my sin square x would be 144 divided by 169. This implies sin x would be square root of 144 upon 169, which will give me plus minus of 12 by 13. But we know that in fourth quadrant sin x is negative, so sin x equals to sin x equals to minus 12 by 13, as sin x is negative in fourth quadrant, right? So now you got sin x, can you get cosec x? Cosec x is nothing but 1 upon sin x, which will be minus 13 by 12. So we have got all the entities. Now let's move on to the last problem of the day, which will be the fifth problem. Again, I've been given tan x equals to minus 5 by 12 when x lies in second quadrant. So tan x is negative in second quadrant, and what else is negative except sin and cosec x, everything else is negative. So you got tan x equals to minus 5 by 12. This implies cotx is nothing but 1 upon tan x, which is nothing but 1 upon minus 5 by 12, which is nothing but minus 12 by 5. You got cotx. Now given tan x, can you get sec theta? So sec square x minus tan square x equals to 1. So sec square x equals to 1 plus tan square x, which is nothing but 1 plus 5 by 12 minus of 5 by 12 whole square. So minus of 5 by 12 whole square, 1 plus minus 5 by 12 whole square will be 25 upon 144, which will come out to be 144 being the LCM. 144 plus 25, which will be 169 upon 144. So this will give me sec x equals to the square root of 169 upon 144, and it will give me plus minus 12, 13 by 12. Now we know that in second quadrant sec x also will be negative. This implies sec x equals to minus of 13 by 12, as sec x is negative in second quadrant. Now we got sec x. Can we get cos x out of this? Yes. Cos x is nothing but 1 upon sec x. So you get 1 upon minus 13 by 12. So you will get minus 12 by 13. Alright. So you can see this is the process we are following. Given tan x, we are getting sec x. Given sec x, we are getting cos x. Given cos x, we are getting sin x. Because we know some of the trigonometric functions. So what is that we get? We get sin square x plus cos square x equals to 1. This gives me sin square x plus minus 12 by 13 whole square equals to 1. Then this gives me sin square x is 1 minus 144 upon 169. If I take 169 as LCM, I get 169 minus 144, right? And this will give me nothing but 25 upon 169. So my sin x is what? My sin is square root of 25 upon 169. which is plus minus of 5 upon 13. Again, my sin x would be positive in second quadrant, so we will take 5 by 13. Since sin x is positive in second quadrant, right? Now given this, can we get can we get cosec x? Yes. What is my cosec x? Cosec x will be 1 upon sin x, and which will be nothing but 1 upon 5 by 13, and this will give me 13 by 5. Okay, so this is what we had to discuss in 3, 4 and 5.